So what? What happened?
I'm saying this is on the quiz. It's gonna take me a little bit more than a minute. Me and math not so friends.
You gotta be able to do something.
We're gonna do something, but I don't know if we're gonna do all of it in a minute.
Okay. So next one. So again, let's put that out. So we have 9 times 16.
You.
I'm just rounding it.
Oh, okay. Should we do
Divided by
that or no?
196. With oxygen, we can round. 8, 2, 6, 7 AMUs times 100. So this is equal to 72, 3.
Yeah.
Point 1,
5.
2.
1, 5. But I did the 15.9999.
That's fine.
Okay.
Percent.
So, depend on the element asked.
Remember, because we all have our periodic tables, we all have different periodic tables, you're going to get different numbers. On the exam, you will have the number I want you to use. Right?
No,
I will give it to you.
Right, no, but I was just trying to confirm, like, in any other process. So it's like, if you want to find the percent composition, you just, whatever element is asked for, you multiply that by the amount.
Yes. Yes.
In that
Yes.
in that
Compound.
compound.
Yes.
And you divide it by the molecular mass.
For the whole thing.
For the whole thing.
For the whole thing. Okay? So now put that, yes.
In this case, you don't have kind of counting the significant figure, right?
This one is fine.
But if I put it all the way out, you wouldn't mark that wrong, right?
But in the exam, you're gonna see how many.
I would ask you.
Points.
I would ask you for significant figures.
Oh, okay. Okay, cool. So you wouldn't just leave it up to us to write it.
No.
You would be like, okay, I need this amount.
No.
Per.
Whatever number I give you in the question, that will indicate to you how to do your significant figures.
But with this one, there's no number in the question, so.
But I would give you the values for all of these.
Oh, okay.
That's
so
where the numbers
so
come
you
from.
wouldn't have to look for that.
Exactly.
Okay, so that's why I was like, I can't do all of this in a minute.
Exactly. This is why I'm telling you that I give you the information on the periodic table, so therefore you don't need the periodic table.
Okay.
Right?
Okay.
So next one. So let's back up. So what's the molecular weight?
For the whole,
Yes, the whole thing.
it's 138.204.
Very good. AMUs, don't forget that. What is the mass of for your oxygens?
47.997.
And then my percentage?
34.729.
Very good. Do we get it?
Yeah.
Good. All right. Now, we're getting into the good stuff. My mole. Mole is a beautiful thing. Okay? Now, if we look at the atoms, where do you find atoms? Inside of elements. Okay? How atoms are extremely small. And working with them is very, very difficult. So in terms of, if we want to know about a magnesium atom, dealing with the mass of one magnesium atom, that's a lot to deal with. Okay? It's very, very small, so we don't want to work with those small values. So we now have the mole. The mole is a unit. A unit that represents a specific number. What number is that? Avogadro's number. 1 mole of atoms atoms or molecule is equal to 6.022 times 10 to the 23 atoms or molecules. The same way you can tell me, if I ask you, for example, how much is in a dozen? How much would you tell me? 12. If I ask you, how much atoms or molecules are in a mole? What would you tell me?
Oh, that number.
6.022 times 10 to the 23rd atoms or molecules. If I ask you how many ounces, no. Yes, how many ounces is in a cup? What would you tell me? 8. So this is the same type of conversion I'm talking about. You have units. Units will give you a specific number. Mole is a unit that is attached to a specific number. If you had 2 moles of atoms, what would it be? How would you find that out? 2 times this. Okay? Alright. 1 mole of atom is Avogadro's number of atoms. 1 mole of ions is Avogadro's number of ions. 1 mole of molecules, Avogadro's number of molecules. 1 mole of anything, 1 mole of people is Avogadro's number of people.
We have that much people in this world?
We have more than that much people in the world. Okay? So again, your Avogadro's number is considered formula units. What is formula units? Formula units are these small things that we have to deal with. These are our atoms, these are our molecules, these are our ions. Anytime you see formula units, you must think Avogadro's number. You must think moles. Okay? So again, what would be the conversion factor for Avogadro's number? Remember, a conversion factor has 2 units.
In the denominator of the right side?
Just tell me what goes in the brackets.
The moles?
There you go. How many?
1.
1 mole and
Avogadro's number?
Avogadro's number of
Something.
something, whatever it is. Okay? Now here you go. This is a way to prove that again, where do you find atoms?
Inside the
Inside your element. Okay? Remember I told you before, you have your carbon element. Carbon element considered the rectangle. Inside of your carbon element, you have your tiny little atoms. But now, how do we know how many atoms are in there? Okay? Each carbon atom has a mass of 1.994 times 10 to the negative 23 grams. What is the mass of the atomic mass of carbon on the periodic table?
1.011.
Minus 2. AMUs. So now, can we figure out how many atoms are in that much of carbon? What do we do?
1.994 times 10 to the 23rd. Multiplied
Don't forget my grams.
grams. 12.011 on the top.
10 to the power negative 23.
That's negative 23? Oh.
Now, what is this attached to though? No,
Mass.
I heard somebody say it. No, starts with A though. These are atoms. This is the mass per atom.
So that would be given, right? And then you have to find the rest? Or
Yes.
Okay.
Okay? So now we want to figure out what do I have here. Okay? So this is what we have. This is your conversion factor. So now we have you start off with your 12.01 grams. Okay?
Because it's 3.
You want to get rid of grams. Where does grams have to be?
Bottom.
So 1.994 times 10 to the negative 23 grams. What goes on top? How many?
1
One atom. Remember, this is the mass of one
atom.
carbon atom. What do we do next?
We cancel the G's.
Cancel out the G's. Multiply across, divide by the bottom. What do we get?
6.22.
6.022
No. 0.22. Times 10 to the 23.
times 10 to the
23
23
atoms.
atoms.
It's not negative 23 no more?
No.
Positive.
It goes up, so.
When you have an exponent on the bottom, when you're flipping it up, when you're dividing it, you're going to switch the sign. Okay?
So that's mean that
Wait,
each
wait.
element in the periodic table is gonna have the Avogadro numbers of atoms.
Very good. So now we can do the same thing for magnesium.
Wait, how did you get the 6? Sorry.
Take 12.01
Mm-hmm.
and divide it by this number.
Okay, so 12.
Yes.
So Professor, the 12.01 is not the carbon's mass number, right?
Yes.
So mass means only one carbon or?
That's only one carbon.
So there's one atom?
So remember, this is your carbon element.
Or
I
there's
got
an
two,
element
three.
mass, right?
Yes, the element.
This
Inside of the element,
has the atom.
you have your tiny little atoms
So 12.01.
that has a mass of this only.
I got 2, 3 though. 0, 2, 3.
Me too.
And that's fine.
Okay.
Okay? So now, if each individual atom has a mass of this, and all of them you know add up to this, we need to figure out how many are in there.
Okay.
How many are in there? 6.022 times 10 to the 23.
Which is
Periodic table, we have the elements mass, right? And by that, we can figure out like even in the example, you'll give us the atom's mass.
I will give you the atom's mass, or I can ask you to calculate the atom's mass.
Okay, by giving them.
By giving you
How many atoms do we have?
just this, and you would know this. This is something that you have to memorize. Okay? So now, let's do the same thing for magnesium. What's the mass for magnesium? 24.
0.305.
One how much?
305.
3.1
0.5.
gram. Round up.
Okay.
Right? So same setup. One atom is what? Tell me the number.
4.037
4.037
times 10 to the 23. Like the negative 23.
grams. So what do you do next?
Times 0. Divided, I should say, sorry.
No. Cancel out.
Okay.
Multiply across. Divide by the bottom. Don't forget that step.
6.022.
6.022 times 10 23 atoms. So what does this tell you?
Same
All the
thing.
same.
Same. So all of the elements on the periodic table contain
Same amount.
the same amount of atoms. So now,
All of the elements contain the same amount of atoms.
yes. 'Cause remember, you think of it, all the elements are this little box. You have atoms inside of the elements, right? How many atoms are there in each element? Avogadro's number of atoms. Yes,
Oxygen gas,
that's a molecule.
that has 2 oxygen atoms inside
Yes.
it, so it'd be 6.022 times 10 to the 23rd times 2.
If I ask you how many atoms are there in 1 mole of oxygen gas?
6.022 times 10 to the 23rd times 2.
Yes. Okay?
So how are you gonna ask the question?
We're gonna get to that now. Okay? So, what also can we tell? What is this number equal to?
Regulars.
One mole.
1 mole.
So 1 mole of atoms in each.
There you go. You have 1 mole of atoms in each element. Now, what can you tell me? Why is it that both of them, both carbon and magnesium, have the same number of elements, but they have different mass numbers? Why?
The size of the atoms are different.
There you go. Your size is different. Who's bigger?
Magnesium.
Your magnesium is about twice as big as your carbon, so therefore, it's going to weigh more. Do we get that? No? Who said no? Heard it. Okay. Now I forgot my next point. Yes,
Would we always have to give you the answer in scientific notation?
it depends on what I'm asking for.
Or just if you ask for it? Or
Yes,
Professor, how long will be the exam?
1 hour,
How many questions?
10 questions.
Professor, why the size is different if the atoms they contain is the same? And
So, as Ronnie said, the size are different. How many neutrons are there in, how many protons are there in carbon? How many neutrons? So that, like that size, right? That's the nucleus size. How many protons are there in magnesium?
is that 20? Six and six.
Let's try again. Magnesium. How many protons in magnesium? Magnesium. Next time. Next time.
Oh, it's 12.
How many neutrons are there?
It's 12. It depends on neutrons.
It depends on the size. As the atom gets bigger, it's going to weigh more. But it's still the same number of atoms in each of them.
Oh, okay, now I understand what you're trying to say. The same amount, but it's just,
The different sizes
yeah.
affect
So
the mass.
it's kind of like if we both buy 5 pairs of jeans, but your size is bigger than mine.
Yes.
Okay.
Okay? So now, what can you tell me about these masses in relation to this?
Wait, come again?
The masses on the periodic table in relation to this concept now.
So 1 mole of carbon, for example, right, has yeah, 1 mole of carbon has 12 grams.
There you go. Alright? So, you get it?
So that's the mass of 1 mole.
Right. So this is the mass per mole of carbon atoms. So now the units, well, our units are changing. Our units on the periodic table now are known. That is a lot, I know. The units on the periodic table now are grams per mole. So all of our molar masses have new units. I was late, so we can't take a break. Sorry. Can't do it. My fault.
And you already cleared out the.
But we will be finishing at 12:30 though.
But live starts at 1.
Last starts at 1, so you just get half an hour.
Half an hour.
Half an hour. Technically, you're only supposed to get 15 minutes.
Not today, Professor. I gotta go.
Well, 8 hours class.
That's what we signed up for.
1:15 is fine.
Well, no, 115 is not fine. Right?
Can
So this is what we just did. Alright? So now, alright? So if you look at what we were talking about again, 1 mole of sulfur atoms contains Avogadro's number of sulfur atoms, which is also equal to 32.1 grams of sulfur. 1 mole of nitrogen atoms contains Avogadro's number of nitrogen atoms, which has a mass of 14.01 grams. Alright? So the atomic masses have now changed units to grams per mole. So now we're going to take some. Your mole is also equal to your molar mass. So now if I ask you, what is the molar mass of sulfur?
It's the same thing as what's here.
It's the same thing that's what's on the periodic table. Okay? So how do we do our conversion factors now? Alright? You have grams. In order to get to moles, you need to find your molar mass. In order to go to formula units, meaning atoms or molecules or ions, we need to use our Avogadro's number. Do we get that? We're going to take some questions to practice. No, don't tell me what. It's
So like what we just did.
what we just did, basically.
What
That's
we did
this.
right there.
Yes.
Okay.
Okay? These are all conversions. So what would be the units for your molar mass?
Grams.
Grams per mole.
Grams per mole.
Oh.
What would be the units for your Avogadro's number conversions? Moles
So wait, units
per atoms.
The first one is the conversion.
They're all conversions.
Okay.
Right? So here, let's take questions. The mass in grams, calculate the mass in grams of 1.35 moles of sulfur. So now, remember our setup, right? What goes on the outside?
What's on the periodic table? What's
No.
In molecular mass.
No. What? Remember, don't forget the setup, guys. Can't forget it.
What you're trying to get rid
Okay,
of.
so for 1, so this is given,
No.
given, 1. Right? So your given is on your left side. What's my given? 1.35 moles of sulfur. Brackets. Now we need, how do you go from moles to mass in grams? What do we need? The molar mass. So what do we have for the molar mass of sulfur?
32.065.
So where does that go?
The bottom. Oh,
Okay, so what's the units for my molar mass?
Grams per atom.
Grams per mole.
So that's 1.35 grams per mole.
No.
Oh, that's just 1.35 moles.
Yes.
Okay.
So we want our molar mass is grams per mole. Which is the unit that we want?
Grams.
So what is attached to the grams?
One mole at the bottom.
1 mole at the bottom. How much grams? Put 32.1 grams. What do you do next?
Multiply.
No.
Multiply cross the mole cross it.
What's it, yeah?
Then you multiply cross divide by the bottom. What do we get?
43.335.
How much?
43.335.
43.3.
Yeah.
Why do we use 43.3?
Because the given has 3.
Very good. The given has 3 significant figures.
So do we have to write down grams as?
Yes.
It's supposed to be written down.
Yes.
Grams. So if it's gonna be only grams, it's not correct.
You have to make sure you know what you're doing. Make sure your unit is attached to what it's supposed to be attached to. You write out the fact that it's sulfur to keep in mind that it's sulfur that you're working with. It's the grams of sulfur that you're working with. Okay? It will get easier once we do it more often and you know how to keep things in order. So what's the next one? The number of moles, calculate the number of moles of sulfur atom in 98.6 grams of sulfur. So how do we set this up?
The given.
Grams.
What outside?
Given.
The given, which is what?
98.6.
What's in my bracket?
1 mole on top. And the math. 32.1.
Minus 2.
Grams
Per.
sulfur.
What do we do next?
Cancel.
Next.
Multiply across, then divide.
What do we get?
3.07.
How much?
3.07.
Minus 2.
Moles.
Per.
Moles of.
Moles.
No moles per gram. You cancel out grams.
So there's moles.
Moles of sulfur.
Oh, okay.
So now I want you to calculate the number of sulfur atoms in 98.6 grams of sulfur.
So it's 3.07 times Avogadro's number.
Times?
Divided by.
Yeah, times.
Times Avogadro's number.
Let's set it up.
98.6.
No, 98.6.
Okay, let's start from the top. So 98.6 grams of sulfur.
1 atom at top. So 1 atom at the top, no? That's what we're finding?
Okay. Is there a conversion between grams and atoms?
No, they're not the same.
You can convert moles first and then to atoms. All right? Tell me.
I think that's 1.85 times 24. Oh, 10 to the power 24.
That's the answer.
Yeah.
I want to know how you got there.
Oh, okay.
Well, you have the moles, you just calculated.
So we have the
So
moles
one-
already.
1 atom on the top.
Okay, 1 atom at the top.
No. From this Avogadro number.
Avogadro's number at the top.
Yeah. Oh, yeah.
Yes, because we're gonna
And
cancel.
divide by 32.1.
Yes.
There you go. Divided by.
32.1 gram.
Yeah.
Gram of sulfur.
Now, why exactly did, who said this? Did BIMS put the grams of sulfur here?
Because we had to cancel it out.
No, but why? But why can't you put this here though?
Put what here?
So what is the conversion factor for atoms?
1 more.
So it's actually 1 mole, right?
Yeah.
Do you see that? Do you know this?
Yeah.
So what do we know about the grams and the moles for sulfur?
Is the not
One
just
mole.
yeah,
Mass
One mole
equals the mass.
is equal to the mass, which is
32.32.
32.1 grams of sulfur. So you can substitute these things. Alright? So you cancel out your grams, multiply across, divide by the bottom. What do you get?
1.85 times 10 to the power 24
What? Minus 2.
atoms.
1.85 times 10 to the 24 sulfur atoms.
So you can't go from moles to atoms. Is that what you said?
Yeah, of course you can.
Yeah.
Use Avogadro's number.
So you didn't start off with the 3.07 moles of sulfur?
We did. Right here.
That's
So this right here is the conversion for the moles. Then you converting it to atoms. So you took 2 steps and you put it into 1. So you can do it 2 ways. So you have 98.6 grams of sulfur. First you convert that to moles. So 32.1 grams of sulfur, 1 mole. Now you need atoms. What do you use for atoms? Avogadro's number. What goes on top? Avogadro's number. What goes on the top? What's the conversion factor for atoms? 1 what? 1 mole. So now you have 2 steps here that you actually combined into 1.
So Avogadro's number is 6.022 times 10 to the 23 atoms.
Per mole.
Oh, okay, I see what I did.
Okay? So now, I want you to calculate in mass, calculate the mass in grams of 1 atom of sulfur. What do we do?
Mass divided by Avogadro's number.
Mass divided by Avogadro's number. So we have 32.1 grams of sulfur divided by 6.022 times 10 to the 23 atoms. So what do we get?
5.33
Tell me again.
5.33 times 10 to the power negative 23 grams.
That's what I got to. Do we see that?
The last question you're asking for the moles and grams?
This one, no. I'm asking you for the mass of 1 sulfur atom. Inside a sulfur element, how many atoms are there? Avogadro's number. What is the total mass equal to of those many atoms?
32.1.
I want to know what 1 atom weighs. So if you had 10 pennies, and I'm asking you to calculate the mass of 1 penny. 10 pennies weigh 60 pounds. What would you do to calculate the mass of 1 penny? Same thing. Okay, let me see what I have next. Okay, empirical formula. Let's take a 5-minute break because my head is about to blow up. Okay? So 5 minutes.